Google Cloud Storage. Our next storage option is where a lot of organizations get started out in the cloud. They need somewhere to put all of their unstructured data. Rather than hosting their own file servers, they can offload that data to Google's infrastructure, which gives us very high reliability, performance, and availability. Let's jump right in and see what cloud storage is all about. So cloud storage is our high performance, internet scale, immutable blob storage. Basically what that means is there's no limit to the number of objects or the size of these objects we can put in cloud storage. Immutable means we can't modify these objects, right? It's create and delete, or in the case of an overwrite, a delete then a create. And blob means binary large objects, essentially unstructured data. And actually one of my favorite terms used to describe the kind of data you put inside of cloud storage is a bag of bytes. You know, it's a place where you just put your bag of bytes. It's not a mountable file system, it's just simply object storage in the cloud. There's virtually no administration on our part outside of managing the objects, right? We can put data up there, pull data down, transfer data around, and of course it's globally accessible. All of that capacity is managed by Google. So we don't have to worry about adding more space when we need it. It's there and it's virtually unlimited. It's also incredibly cheap. We only pay for what we use. It's very simple to use. And we can optimize these containers known as buckets, which are where our objects are going to live, based on the kind of data that lives in them. So we have full control over cost, performance, latency, availability, and durability. Plus, we have all the ways you can think of for accessing data in cloud storage. We've got our web UI up in the developer console for simple administration. We have a command line utility for our operations teams, and we have APIs with client libraries on top of them for developers. Now, when we create these buckets, we need to specify three things. We need to specify a name, which needs to be globally unique across all of cloud storage. We specify a location, which can be regional or multi-regional, and we need to specify a storage class, which is what we have here. We have three storage classes: standard, DRA, durable reduced availability, and nearline. Standard storage provides us with the highest durability, availability, and performance. Availability, 99.9, and a bunch of nines after that percent. Performance, our time to first byte is in the millisecond range. So standard storage is perfect for data that is frequently accessed and requires low latency. DRA, or durable reduced availability storage, gives us the same durability as standard storage, but with a lower SLA. In fact, it's 99% rather than 99.9%. And the cost is a little cheaper as well. It's currently 2 cents per gigabyte a month. Standard storage is 2.6 cents per gigabyte per month. And these are moving targets, of course, so keep your eye on the pricing page to get the current up-to-date pricing. But DRA is going to be good for backups, where durability is the top priority over availability. Our relatively new kid on the block here when it comes to storage classes here in GCS is nearline storage. This is cold storage, right? This is our cold storage. It provides extremely low cost, 1 cent per gigabyte a month, highly durable storage, great for archiving, online backup, or disaster recovery. Now here's the kicker. This is cold storage, which usually means offline storage. Hence the name nearline there. It's virtually online. In fact, competitors out there, and I'll give you an example. I'll pick on AWS here. Glacier. Glacier is offline cold storage, and your time to first byte is 2 to 5 hours. Hours. Nearline, 2 to 5 seconds. So, yeah, that's kind of incredible. And so you're not waiting hours or days to get your data. You're waiting seconds. So extremely cheap, highly durable, cold storage. Again, great for archiving and disaster recovery. Let's get up to speed on the components that make up Google Cloud Storage. These are the things that we're going to be working with when we configure our buckets and we put data inside of them. So data is organized into what are known as buckets. And these are configured with the storage classes here that we just looked at: standard, DRA, and nearline. All buckets share a global namespace. So that's important. That means when you define the name of your bucket, it needs to be unique across all of cloud storage. And yes, we can have multiple buckets within our project. In fact, that's the first thing we'll do, is create a bucket, specify a class, and specify a location. So here we have two buckets. One is standard and one is nearline. And buckets then store objects. Objects are comprised of data as well as metadata. Objects themselves being the bag of bytes, and metadata tells systems and browsers how to handle your data. So you have system metadata such as content type and encoding and language, and then you can also add your own custom metadata, key value pairs, to our objects. Now, buckets and objects cannot be nested inside of one another, but as far as objects go, we can simulate folders through the object's name. So cloud storage is one big flat namespace, but again, we can simulate hierarchy by adding forward slashes in the object's name. Now, when it comes to security and sharing and collaboration, There's a couple of ways we can do this. If we want to give team members administrative access to be able to create buckets and manage buckets, we're going to need to do that through project permissions. Again, we've got the owner and editor roles to help us out there. Now, if we want to give users access to our buckets and the objects within, we have ACLs, otherwise known as access control lists. These sit on top of Google accounts and allow us to grant specific levels of permission to our buckets and our objects. So we have reader, writer, and owner roles, reader, writer, and owner for buckets, reader, and owner for objects. We also have default ACLs at both the bucket and the object level. These are essentially templates. So the first time you create a bucket, it's going to get its initial ACL from the defaults. And we do have full control over those, so we can modify what those default ACLs look like. We can also expose our objects publicly by using a special scope identifier known as all users. So we can put that in the name when we define our ACL. And there's also a checkbox in the web UI that will do that for you. Also, just a note on Google accounts. When you define an entry in your ACL, you can specify for the entity here a specific user. So you put their email address in there. You can specify a Google group, and you can even specify a domain. We can also give anonymous access to our objects through what are known as signed URLs. These are really cool. They're essentially time-bombed URLs that we can create for a specific method for a specific duration. And obviously, you're going to be generating these from your application, but GSUtil also allows us to do it just for testing and one-off purposes, as I did here for our flowers.png image that I have in our CP100 Happy Bucket. So I did a GSUtil sign URL. The method is get, meaning people will be able to read this object, and the duration is for 1 minute. And here's what it gave back, a URL. So this URL is good for 1 minute to access that object. But you can do that for reading, writing, and deleting objects. Speaking of GSUtil, this is our command line utility in the SDK that allows us to work with GCS resources. Buckets use the URI scheme gs://. So anytime we reference a bucket or an object, we need to prefix it with that. So here's a couple of examples here. GSUtil with an ls will return the buckets inside of your project. A GSUtil ls with a specific bucket, like we have here, will return the objects within those buckets. And then if we do a CP, which is a copy, we have our source URI and our destination URI. This would copy all the information from this bucket to our local machine. And just to give you an example of that, I've actually got the Cloud SDK set up locally here, GSUtil, and hooked up to our CP100 project. If I were to do GSUtil ls, this will give us the bucket that we have in there, CP100 Happy Bucket. And if we were to reference that bucket and do an ls against it, CP100 Happy Bucket, this will give us the objects within that bucket. So if you want to see a list of all available commands, just run a GSUtil. It'll give you a list of all those commands with a brief description of what they do. Now, we've got a lot of great features around cloud storage. Things like website use. We can actually configure a bucket to serve up a static website. We also have regional as well as multi-regional buckets. So a regional bucket allows us to put our data in a specific location to further optimize latency, availability, and network bandwidth. So if you have users or compute engine instances or app engine instances in a specific region, you can put your buckets there to improve everything. If not, if you have users all over the place, then you can use multi-regional buckets. So your data is distributed across many regions. We also have object lifecycle management. This is really cool. This allows us to create policy to allow cloud storage to perform actions on our objects based on certain conditions. So we can say delete objects that are older than X number of days, or delete objects created before a specific date. And this can also work with object versioning. This is another cool feature that when enabled on a bucket, all the objects in that bucket will maintain their history. So that'll give us a way to undelete data or retrieve older versions of our data. We also have an online cloud import known as the Cloud Storage Transfer Service that allows us to take data and bring it in to cloud storage. So we specify a source, and that source can be an Amazon S3 bucket, it can be a list of URLs, or it can be another Google Cloud Storage bucket. It makes it very easy for us to get data into cloud storage from wherever it may be. On the flip side of that, we have an offline import. So this is actually a third-party provided service. There's a couple of providers out there, and we can ship them our storage devices, disk drives, tapes, flash drives, whatever, and they will upload the data to cloud storage on our behalf. So this will be really helpful if you have a slow or expensive internet connection and a lot of data to get into cloud storage. And finally, we have object change notification, a great feature to integrate into your applications because this will allow developers to create webhooks onto our objects. And if anything happens to those objects, it'll call back to our application where we can take action. As if cloud storage wasn't awesome enough already, these features make it that much better. Cloud storage is everywhere. I don't think there's a reference architecture I've seen that doesn't have cloud storage somewhere in the middle of it. It's such a great place to put things temporarily, permanently. It's a staging area, it's an integration point, it's everything. And that's why you're going to see it used with a lot of products and services here in GCP. You'll see it used from BigQuery to import and export tables. Again, cloud storage is a great staging area before you ingest that data into BigQuery for analysis. You'll see it used from App Engine to store objects and export logs, from Compute Engine to store startup scripts, and again, general object storage. And you also see it used from Cloud SQL to import and export tables. Let's finish this nugget off by jumping into the web UI and taking a quick peek at where we can find cloud storage. So here we are, console.cloud.google.com. We've hit the products and services drop down here. We can head down to the storage category, and there it is, storage. So let's pin that down for future access. If we click on it, it'll take us right there. And here we go. We've got a browser. And initially, it's going to take us into buckets. We can create buckets. We can go into our buckets. We can manage our buckets and our objects right here in the web UI. On your objects, you can hit this little build button over here. You can edit permissions, metadata, copy, move, and rename your objects. Here is the online storage transfer service. So we can hit create a transfer here. We can specify where our source is, another cloud storage bucket, an Amazon S3 bucket, or a list of object URLs. And then we can select our destination, which is going to be a cloud storage bucket. And then we can configure our transfer. We can even schedule it for a specific time if we wanted to. And then we've got a couple of settings in here as well. So that's about it. There's cloud storage in a nutshell. Check out our lab immediately following this nugget to get a little more hands-on with cloud storage. In the CBT nugget, we got familiar with Google Cloud Storage, our highly durable, highly available object storage in Google Cloud Platform. I hope this has been informative for you, and I'd like to thank you for viewing.